All right, good afternoon, everybody. I hope everyone's feeling awake. It's past lunchtime. I'm going to talk to you about continuous deployment at scale. A lot of the things I'll talk about work well, are more usable, applicable for medium to large scale projects that are more long-term. But I'm sure you can take about bits and pieces and apply to projects of all scale. So how many of you have heard of Etsy? Quite some, many not heard of Etsy. Etsy is a marketplace where buyers and sellers meet both online and offline to exchange unique goods. You can think of it like your weekend market where people buy interesting things like maybe antiques, maybe handmade furniture, ceramic. So this is that online that works every day. So to give you a sense of the scale we're dealing with, we have around 1.6 million active sellers, 24 million active buyers, a little under 2.4 billion in GMS last year. That's gross merchandise sales, and around 820 employees. So my name is Premshree Pillai, and I'm a senior engineer at Etsy. I've been working at Etsy for the past little over 5 years, and I used to work at Yahoo before that. And I don't really know how to pronounce it, but hello. It's my first time in Estonia, so I'm very excited to be here, and I think we all got very lucky with the weather. So I've divided the talk into 3 sections. I'm going to talk a little bit about the principles that are in place, that we have in place for our continuous deployment stack, a little bit on the tooling and culture we have in place that enables us to have a certain kind of deployment process, and we'll end with some Q&A. A lot of the things, we had quite a few talks about continuous deployment and principles, and a lot of them will be a little bit of overlap, so excuse me for that, but hopefully it'll still be interesting. So principles, there are a bunch of rough guidelines we can keep in mind when we are trying to develop our continuous deployment cycle, and it's important that we have certain principles in mind, because that's when you know, that's when you can actually build tools that work for you. So the first one is just ship. It sounds a little obvious, but often this does not often appear in any of the guidelines when you want to build a continuous deployment pipeline. And you should, making it very explicit makes you aware that this is your primary goal. You want to be able to ship products quickly. In addition to shipping products quickly, what do you want as a product team, as an engineer, as a developer? You also want to be able to innovate quickly. So we want our continuous deployment pipeline to allow us to enable innovation. In the end, we are shipping products. We are not shipping code. And as people who build stuff, engineers, designers, craftspeople, we are driven by certain intrinsic motivators. We want to optimize for purpose, autonomy, and mastery. We don't ever want our continuous deployment tools to be a hindrance to any of these intrinsic motivators. We, in fact, want our deployment tools to be enablers of these. We also want to be able to experiment. Whenever we ship products, we're never going to build anything perfectly, and that's okay. But we can make measurable improvements to our products using data, and we should be able to do that. And we can do that with A/B testing, for example. So if I want to check a particular feature, a particular module on the homepage of Etsy.com, say, and I want to check what version of that particular module works better, I should be able to do that quickly. We want to iterate quickly. We want to be able to improve product features and keep pushing our products. We would rather fail fast than have stagnant code lying in our code base for a long time. And so baked into the idea of continuous deployment also needs to be the idea of continually improving your processes. So you can't improve your processes if you don't have a way to do that, and you need to factor that into your process also. And we want to optimize for a low mean time to recovery. So things are going to fail. You can't prevent that, but you want to be able to recover quickly as reasonably possible. So I'll talk to you about some of the tooling we have in place that allows us to deploy continually. I won't get into very details of the specific tools, but if you have questions of it later, we can talk about it. Now, before we get into the tooling, what does a typical continuous delivery deployment cycle look like? So typically, and this is normal, a developer or designer commits some code, which triggers perhaps some automated builds, which triggers some automated tests, perhaps then some user testing, and then you release. And between each of these phases are also feedback, so that if any of the steps fails, so for example, if a developer or designer commits a piece of code, your build fails, you can't proceed to the next step. So frequent check-ins, we do, so now we'll talk a little bit about like the specific things we do in terms of the tooling in order to achieve this. We check in very frequently, and we check in to master. And like to a lot of people, how many people here use GitHub? Quite a bit. Like one of the great features of GitHub is branching, but so I think when I tell people that we don't actually use that, people are a little surprised. But this works really well for us. It means you're just constantly shipping smaller pieces of code. And we do that by branching in code. We have a library called feature that's available on GitHub. So for example, this is just a simple configuration in one of our PHP files. Here it's telling us my feature is enabled, it's enabled. If this particular feature was not enabled, it would just be, you just turn the configuration to off and it's disabled. And in your application, you can have a feature be enabled for a certain percentage of users. So here what it is telling us is my feature is enabled for 1% of all users. You can also bucket features. So in the previous case, it was 1% of all possible users. Here you're saying, I want to bucket it by user, meaning if a feature was available, turned on for a particular user, they will consistently have that same experience. So you bucket by user. So a check on your application code, we use a lot of PHP. So in our PHP code, this is how the config check would be like. You just do if feature is enabled, you do a bunch of code. And if it was bucketed by user, you pass in the user, and you do the same kinds of checks. So in the same vein as feature flags, we have A/B testing. So for example, instead of having a feature that's either on or off, you may have a feature that's enabled with different variants. So here what this piece of code is telling is my feature is enabled, and it has three variants. Layout 1 is enabled for 1% of users, layout 2 for 3% of users, layout 3 for 3%. And so in your application code, when you want to check whether a feature is available for a user or not, instead of checking just for on or off, you would check what variant of a feature is enabled for this user. So, and each one will have its own block, however you want to define that. And so all this ties into continuous integration. Whenever you are checking in code, you trigger builds. And you always want to keep the build green. That's your end goal. You never want to leave work without having a green build. And you want to be able to release anytime. So I'll talk a little bit about the specific tools we have in place for a lot of these things. Actually, I think Igor talked about something similar in the org track about pre-flight builds. So this is a similar idea. Whenever any designer or developer is trying to commit code, before they commit the code, they run something known as try. Try is basically a Jenkins plugin that sends a patch of your working copy to master, patches it up, and runs all the tests. So what that does is, like, before you are ready to deploy, you know that your chances of you breaking build are 0 because you've tested that. So this is available on GitHub. And so once a person runs try, they see that, OK, things are green. And then they move on to the next step. It's time for you to deploy. We do this using Deployinator. It's a tool we built in-house. It's an atomic deploy tool, also on GitHub. This is just a screenshot of the deploy tool I just wanted to show. So once people are ready to push code to production, there'll be some automated tests. Then you look at the Jenkins screen, all the tests look good. Then you perhaps do some manual testing, and then you release to production. So in the Deployinator page I showed before, this is the production button. So there's just one button. That's all there is to it. And of course, like, each of these steps has a feedback cycle. So I earlier omitted the fact that there's 2 environments. There's not just production. There's Princess. Princess is basically our pre-production environment. Princess is basically exactly boxes that are production boxes, but that are depooled, so that you can replicate whatever is on production without actually getting any user traffic. So before I actually put anything into production traffic, I can do some manual testing, make sure things look okay, and then deploy to production. And anybody can push. Like, there have been random people coming into the office sometimes. Like, everyone, like a venture capitalist came one time and he pushed code. It's very easy for us to get people set up with this. Every engineer who joins the company, the first day they do a production push, which is the push itself is not hard, but getting into that frame of mind that it's okay to do a production push, that's the hard part. So all of this is not to say that production push is trivial. You need to be anxious. You need to be you need to have some amount of healthy anxiety before you push to production. You should be ready to test what you're about to deploy. You should be aware that what you're about to deploy has real consequences for millions of people. So you need a healthy balance. You have a lot of power, but you need to exercise it cautiously. But what you don't need is to be afraid. You've taken a lot of steps. You've run try. The build is green. You've done some user tests. You have pushed your code to production. There's a lot of intermediate steps that are already automated, so you don't need to have cognitive overload of what you need to worry about. So you don't need to be fearful, but you need to be anxious. So like traditionally, the relationship between developers and ops in the traditional model is always adversarial. Developers develop some code, hand it off to ops pushes it. I know this from experience. I'm sure everyone here has experienced it. But in this model, the relationship is more collaborative instead of one where it's adversarial. In addition to the typical the cycle that I talked about, we have the idea of dark changes. Dark changes are changes that you have extremely high confidence in that will not break the build. So like some examples of what might constitute a dark change is a template change, simple CSS tweaks, or unreferenced code. So because we use feature flags for branching, a feature may be completely off. If I'm changing something in that unreferenced block of code, I can push it without actually going through the whole cycle. And by convention, we just mark dark code as dark. And so anyone who is actually pushing the code to production knows that this code has possibly no impact, very, very low impact. I don't need to worry about it. This is just a convention, and this is because you want to be able to push as fast as possible within reason. And this works really well, especially with like simple things like template changes. You can change the definition of what constitutes dark depending on what kind of project or product you're working on. In addition to a normal deploy cycle, we also have a config push cycle. So if I have a feature that's initially enabled to 1% of all users and I want to turn it to 50, I don't need to go through the whole process of actually deploying code. We have allow for a different push cycle so that that can run parallel and independent of the traditional push cycle. So how do we do pushes? So we orchestrate a push through very old school coordination of people via IRC. And so the channel topic that you see there, that's the topic of the push. So what it's telling us here is there's two push trains. One train has 5 users and one train has 1 user, ASN. And so anytime I'm ready to push, I go to this channel. We have a channel called push. And right now the topic is John. John is pushing code and I join in. So once I say join, the channel topic changes to the both of us. And the person who's at the head of the train is the driver of the train. So he or she is the one who is actually going to push the code or do all the operations. And so at various stages, so before I commit, after I commit, and also during the pre-production environment, I need to let people know whether my changes look good or not. So when I say .good, or different language, I get an asterisk so that the driver of the train or whoever is in the train knows that they can proceed to the next step. So, and at this point, if someone else wants to join the push queue, Sally wants to join, because a train is already moving, Sally will get her own queue. So push bought the topic grammar, and the channel grammar is written in Antler. It's also available on GitHub. So now you joined IRC, you used Deployinator, and now it's time for you to gain confidence in the work you did. So post-deploy, we have a bunch of tools that we use in order to gain confidence. This is why I mentioned before, you need to be anxious, but you don't need to be fearful because we have these tools. So post-deploy, we have tools that will let you figure out whether your changes are good or not. And supergrep is one of them. Supergrep is basically just an aggregation of all the error logs on various systems. So so once you deploy and you see that a specific kind, if there's a surge in a specific kind of error, you can correlate that with a particular push that just happened. And of course, we use plenty of dashboards. So these are some general purpose system-wide dashboards at Etsy. So 404 errors, iOS crashes. And so every time there's a deploy, and let's take the 404 graph, for example. These vertical red lines that you see are push lines. So if there's a certain surge in 404 errors happening after we do a push, we can correlate when that happened with potentially what push. And so then you can narrow it down to what commit may have caused that. And each team has application-specific dashboards in addition to, because there are so many different sub-products within the entire application. As a product engineer, what becomes relevant to you is your specific subsystem. So in this case, this is the shipping tracking systems of Etsy. And so every time I deploy code that's related to shipping tracking, I am going to look at these dashboards and see if anything I pushed may have affected something. And if there's a shift in pattern that's not desirable, we can correlate that to a particular commit. So we use StatsD for that. It's also on GitHub. So to give you a rough summary of the various steps we have and the tools we use try, which basically sends a patch of your working copy to what's on master, and then runs builds, runs all the builds and tests on it. We use a bunch of Git hooks. We use some static analysis. Once you're ready to push code to production, we orchestrate that using just a push train using a push bot via IRC. And the actual tool that you use is Deployinator. We do some user testing. And then you look at supergrep and dashboards to make sure what you push looks OK. So does anyone know what this is? RJ45 Ethernet cable. How many ways can you plug this in? How many ways can you plug a USB cable in? I think people often have a problem connecting USB cables, right? So the Ethernet cable is a great example of poka-yoke, which is Japanese for mistake proofing. So when we want to think of our deployed tools, it's a useful metaphor to have because we are all going to make mistakes at some point. But what we can do is to make these mistakes minimal. We can solve problems. We can solve a lot of problems with technology. And when we have this metaphor in mind, we can solve it well. So I'll talk a little bit about culture, because culture is often underlooked, and I think it's a very big part of how you can successfully have a continuous deployment environment. Nobody creates culture. Nobody assigns culture. Culture needs to be fostered. You can create an environment where people are happy, empathetic, and productive. So there are some basic guidelines we can follow when we want to think about what kind of culture we want to create in order to be able to have a successful continuous deployment strategy. The easiest one is you have to assume best intentions. No one here is trying to do something wrong on purpose. We are all trying to solve a problem. We are all here to do a specific kind of job. And we may make mistakes, but no one is intentionally trying to make a mistake. We want to cultivate empathy. It's always useful for me I'm a product engineer. It's useful for me to know what it's like to be an operations person or what it's like to be in support. Knowing what it's like to be in someone else's shoes is an easy way to know what it's like to be that person. It's an easy way to cultivate empathy. We also want to be open. We want to be open to critique, ideas. And failure is an option. Now, I don't want to overstate it, but I think it's a mistake to think failure is not an option, because everything will fail, whether it's humans, whether it's machines, things will fail, and you have to accept that that's a reality. It is definitely not our intention. We would very much like not to fail, but despite our best efforts, we will fail, and we have to accept that. But failure is also an amazing opportunity, because it's the only time you can actually learn from your mistakes. And we do that by conducting what we call post-mortems. So say Etsy.com went down, and then after we try to get it back up, I think the immediate thing to do is to figure out what actually went wrong. There's a lot we can learn from those. And these postmortems are not meant to assign blame to any person. It's not meant to say this person did something wrong or another person did something wrong. It's to figure out what the problem actually was and to make our systems more resilient. So these postmortems often lead to tasks that we call remediations. So that in the future, if we were to encounter a similar situation, we know that would have been taken care of. We use a tool called morgue, appropriate, to document all the times there was a failure. And so this is great because not everyone is always involved in every failure that happens during a production cycle. So it's a great way for me to go learn from other failures that may have happened in the past. So I can go back to a specific failure, and I hopefully am learning something from that. We also used to give this award before. It was called the Three-Armed Sweater Award for the most spectacular failure of the site. But it's not meant to say, hey, we should all fail. That's not the point. The point is, like, failure means you're learning something very useful. So in that sense, it's really helpful. You shouldn't be afraid to fail. We also have this tool internally called Mixer, which basically, like, every 2 weeks, it will send out an email and pairs you up with one random person from the organization and says, hey, maybe you guys should go get coffee. So it's very useful because I, as a product engineer, may primarily interact with product designers, product engineers, but I may not interact with support very often. So it's a great way for me to meet other people in the organization, know where they're coming from, what problems they face. And also, when you put a face to a name, you're probably going to talk, you're not going to fight. It's possible to have real conversation. So just to summarize most of what I talked about, so a combination of culture and tooling allows us to deploy very often. Most often we succeed, sometimes we fail. And when we fail, we do postmortems of what actually went wrong, which leads to some remediation. And this feeds back into our system so that it becomes even more resilient. Now, this alone is not often enough. In order to make our systems resilient, we sometimes need external stimulus. You need to constantly ask questions. Could we change our processes completely? Could we do our database deploys differently? So you need external stimulus also, in addition to the learnings that you gain from your system failures. And so, like, this is a deploy graph. The green ones are block deploy, but the yellow ones are web deploys. So that's over 40 deploys a day. We do at least 30 plus deploys, web deploys a day, and 30 plus config deploys a day. So that's 300 deploys a week. There's a lot of other information on the Etsy Codascraft blog if you're interested. But that's all I got. So if anyone has questions, happy to take them. Thank you. Yep.
I have plenty of questions. First one, why do you use this? Let me phrase it differently. You are not forced to use try. You can skip try and go to build and break it. That's cultural thing to use try.
Yeah, you're not forced to, but once you go to the push train, and if try would have failed it, this process would have failed it.
Okay, that makes sense. Why not use branching? Because branching is basically giving you the same thing, but forcing you to basically try it instead. So the branch is being automatically tested, and then you merge it only after the screen. Well,
I guess the way I'll answer that is to ask you why use branching, because we solve that very easily without branching. There is one less overhead in not branching. We just check in code to master, and we run try. The overhead in running try is much lesser than us trying to create a branch, commit it, and have a merge bot do the build. So we just don't do it.
Okay, it sounds a little bit awkward because the GitHub basically does everything they can to help you out with creating branches, merging them in. It's basically like a button click, or if you don't want to, even not that, it will basically just push the branch and it will merge it automatically for you.
Yeah, I understand that GitHub does branching very well, but I think it's a matter of like how you want to do it. Like if you're committing code very, very quickly, your code changes are very incremental. They're very tiny changes. So the overhead in actually committing code directly to master for me is far lesser compared to me wanting to branch and then running those tests. So, I mean, I'm sure that could also work, but this works really well for us too.
Okay, cool. You use feature switching library.
Yep.
How do you keep the bucketing information? Is it just stored within the session of the user, or you kind of push it into the cookie?
It's in cookie. Yep.
So it's available all the time.
Yep.
Have you ever considered running two features side by side but never showing the result?
How do you mean?
I mean that you have two options. You implement something like a safe direct feature. It's never being shown to the users, but it's still being executed. So you can compare results.
Yes, we do. Yes. We do that sometimes, especially with more infrastructure-related changes. So if we are switching, if we have refactoring rather, if we have refactored a particular API, we want to make sure that the old results match the new results. Within the code, we might log it and just make sure just throw out an error every time there's a mismatch, and those kinds of things we do. Yeah. Yep. Yeah, so the config block that we do in PHP is just a PHP array, and within those arrays you can have subarrays. So if a particular, say, a product team that's working on shipping there are multiple features. There's shipping tracking, there's shipping labels. So both those teams may have two separate flags within a parent shipping flag. So there could be a flag called shipping labels, shipping tracking, and like I said before, I think one of the advantages when you are pushing code very incrementally is they're very contained. There is very little dependency on someone else's code being pushed because you're pushing that frequently. So that's one way we manage it. Occasionally there are problems, and then our strategy then is to roll back. Yep.
How does your A/B testing process look like? The kind of business person tests something himself, or does it always require the developers' involvement? And also, how do you manage the statistics and the dashboarding and the analytics part of the A/B testing?
Yeah, we have a tool internally that allows. It's just a GUI, so that allows you to set up A/B tests. And we have a calculator for calculating statistical significance, so you know how long you will need to run an experiment, or for how many users to know when your experiment has gained statistical significance. So there is some developer work involved, like maybe in setting up the flags, but in analyzing the results, there is no work involved. It's just a dashboard that's internal.
And you have a separate database for the results?
We have a bunch of aggregate databases, so we use those for analyzing those results. Any other questions? Yep.
You build up a lot of nice tooling and you open source that. Do you have like assigned time to improve and build that tooling, or you basically need to find that under the radar and like kind of force your PMs, like I really need to work on the deployment?
I don't have a very good answer because I think it depends on each team, but I think it depends on we are only solving problems that we face. So if we face a problem, we are probably trying to solve it. And if we think, oh, this seems like a lot of people could benefit from it, we might take some time to try to open source it. But there's no specific process. It just depends on the team and the person.
Okay.
All right, I'll be around if anyone has any questions. Thanks.